Welcome to KBYP's second video on the Eimac care and feeding and broken tube computer with a little good old 80s Midas touch. If you're looking for the answers, you found the right place. You might even find more questions here than answers, but that's what makes it fun. The first video left off at the point of only having 1 point, and 1 point does not a line make. It makes an infinite number of lines going an infinite distance. For this tube, we must have a plate current maxima of about 1.2 amps someplace up in here, because that's between the lines for 1 amp and 1.4, so 1.2 is somewhere in the middle. It takes 2 points to make a line. 2 plus lines make a two-dimensional plane. That relates to operating areas, like this upper left distortion region. In transistors, you'll see SOA graph, safe operating area. It defines, or is defined by, maximum current. That defines maximum dissipation, operating either side of the distortion limit, which is not a hard and fast limit. That's pretty much a build it and try it and vary it and see what the IMD does. It defines the minimum plate voltage, which then does what I don't want. It defines the midpoint R sub P, or plate resistance. The midpoint resistance is somewhere between the maximum plate voltage and the minimum over here, somewhere around 500 volts maybe. Because if we follow that 500 volt lineup, it goes into that distortion region. So maybe 500 to 600. Why don't I want that? Because this design is coming from this particular set of operating characteristics and not from the graph. The graph is being done to verify these. It's clearly stated 2 kV plate supply, 62 milliamps, zero signal plate current. That's easy to measure. 400 mil single tone plate current, that looks like a calculated value because it's one significant figure. It's easy to dial in 2 kV. But 2750 looks to me like an input value. Somebody chose that. I don't know what their intent was, but that's my take on it. Notice there are other numbers here that look like they might be maybe calculated after the fact. A grid meter is probably not going to read 148 milliamp, but that's what the figure is. That might be an indirectly calculated value. I don't know, and they don't say. But the problem with choosing the upper point first is that it defines a midpoint resistance value. If it's not 2750, then I got to move the upper point. So I'm going in circles. Going off the proverbial reservation, what I've done is not drawn a plate line, but a plate resistance line approximately over a fairly short interval. And I'm using the assumption that the plate resistance is a median value in the middle of the operating range. And that kind of implies that the voltage, the plate voltage change, let's say it's here at 1250. The plate voltage swing this way will be 750. So that suggests that the plate swing this way will be 750. And 1250 minus, really hard to do this and look at a calculator. 7 minus 750 equals 500. And that would define the minimum plate voltage as 500 here. And that would project up to this line, where after the plate operating line would be from this lower point down here at zero current through that 1250 volt line vertically, which into 2750 ohms would be 454 milliamp, and that would go up and intercept that 500 volt line. See, that's inside to the upper left of that rather arbitrary distortion line that I drew. Okay, and there's nothing accurate about this line. I just threw it in to illustrate a point. When they designed this initially and tested it, since they specified that the case is minimum distortion products, they probably chose 2 kV. And they set the tube up, and they may have done this. That's what I would do. I'd use the design process to set it up and operate it. And then I'd vary the drive, the grid drive, and I'd vary the plate voltage to find, drum roll please, minimum distortion products. Because there are two opposite cases here, maximum power out and minimum distortion. And as extremely perfectly tuned as my antennas are, I don't need maximum power. I just need a little bit of help. I could use 200 or 300 watts now and then. Most of the time I don't need it. So what I would do is vary the parameters here, and there's basically 2, plate voltage and grid drive, because that defines the transconductance, or the gain figure. And along with heater energy, which according to care and feeding accounts for 5 to 10 milliamp of plate current per watt of filament power. That's a very subtle and critical point. Never try to run an amplifier like this with an insufficient heater supply. It'll flat top. Then, with only 2 variables, we just vary the variables while looking at a spectrum analyzer or some such thing and find out where that minimum distortion occurs. And that may have been at the point where they took measurements and wrote these values down. That would be the obvious path to get there. So what I'm trying to do is I'm trying to read their minds and work this backwards. I just kind of sort of grabbed 1250 as a midpoint based on a minimum plate voltage going much lower than 500 is quite likely going to run into this distortion region. And they don't state over here what the maximum current is, what the maximum plate current is. They say single-tone plate current, which is 400 mils, but that's a number to one significant figure, and I don't trust it. I don't trust it as being a measured value that I can take to the bank, because I see that agrees exactly with their initial process of making an assumption for plate current before testing the case for a minimum distortion. And that 400 milliamp DC is going to be kind of an average ballpark number as we read on a meter, maybe. I don't trust meters any further than I can throw them. And so I pencil in that line with pencil, because I drew this distortion area, and with pen it's not accurate and I can't erase it. So, but it's cheap and easy to print these out. But there's a load line, no guessing at the maximum plate current. And this is probably going to be underdriven enough and low enough power case that no matter where this is about in this ballpark, it's not going to overdrive the tube. We sure don't want it to be up here. But this starts at the 0 drive plus 10 volt grid voltage at 0 plate current. Goes through the midpoint, 2750 ohms. I'm sorry, 1250 volts divided by 2750 ohms from the data sheet is 454 milliamp, reasonably close to the 400 milliamp figure. If you want, refigure this 2750 ohms times 400 milliamp gives 1100 volts. And if you want that, then go find the 1000, 25, 50, 75, 100. Correction, 1000, 1050. Pardon my mistake. If that's what you want, go to 1100 volts, 400 milliamps, project up to this point, and then redraw that line, like such. But any number of these lines will work with a 2750 ohm midpoint resistance, provided that my definition is correct of that being a midpoint and the voltage swing being the same either way. Now it kind of looks like if we take 1250 volts minus 1100 for a difference of 150, half of that is 75. 75 minus from the 500 volt line is 425, so that puts the min plate voltage intercepting this line about up here. That pretty clearly seems to be on this more or less linear part. And that's probably the line they're looking for. So take your pick. Maybe vary it slightly either way. Most of the reason I'm doing this, going off their instructions, is that my goal, acting as an engineer for practice and for fun, is that I intend to completely calculate this as a brand new design with all modern components, toroids instead of open solenoid coils. I'm going to make my own high voltage capacitors because they're horribly expensive. I'm making my own tube socket, dissipating cap, different chimney design. Everything is going to be redesigned, partly because we can't really get these legacy parts anymore. Tubes are hard enough to find. But glass chimneys are a thing of the past and sockets are harder to come by. So I've made my own new of everything and better. But I intend to have this calculated down to every component. I will put it together. I will sweep test everything. I will attempt to find any stray resonances and eliminate them, so that when I first fire it up, the two common things don't happen. Firstly, the thing's out of tune and reefs on the plate by drawing too much current, or as one of the hams in my broadcast group said, he built a tube amplifier, turned it on, and the plate turned white. Scared the bejeebers out of him because it ran away from oscillation. He said literally turned the plate white, not a dull red. Said it cooled off, worked fine after that, but I don't want to go there. If I really have engineering knowledge, I should be able to calculate this to be very close to working the first time, especially because they're giving me much of the information. But I should be able to go calculate the output network, which I've done. I should be able to calculate the switching, the reflection coefficient, and all that with the relay switching, which I did. See the impedance matching video on this channel. And be able to set up and tune the input correctly, which turns out to be a much more difficult problem than any of this. I'll do another video on that later. Now to the horrendous problem that I mentioned to you with the tube computer. This is a computer. This is what's used to calculate reasonable figures for power output, for harmonics, for grid drive and all that. And the process is that this line has a certain length. And when that line length is made coincident with this line and the line down here implied where the printer cut it off, say it's the length of this diagonal line. When that diagonal line is put parallel and right on top of that line, then these radial lines indicate current levels. They're then put into these very simple formulas to calculate DC current meter reading, peak fundamental RF energy, peak second harmonic, peak third harmonic, output power, and driving power. And the proof in the pudding is that those jive with those numbers. They made a serious mistake in recreating this document, and this has been recreated on the computer. They confused putting the operating line OG with step 2, and it should be step 1. And when that's done, this computer graph will be upside down and get the numbers for these plate current readings essentially backwards and get the wrong answer. To catch this mistake, go back and get an old version of the care and feeding document from the 60s or 70s and read it in section 3. Because the new document has this mistake in it. But when looking at these texts, it's really important to go back and get the classics.